Hello everyone, and thank you for joining me as we take a look at Chapter 12. There's a lot of things going on in environmental science today, and we got to be wise about it. And hopefully you guys can learn a little bit more through what I'm going to be teaching you in Chapter 12, specifically as we start Chapter 12.1, the Environment and Pollution. Let's take a look. You see, environmental science studies the interactions of the physical world. In the universe, there's divisions into two different factors, a biotic and abiotic factor. A biotic factor is a living factor, and an abiotic factor, sorry, there's a lot of A's in there, is a non-living factor. Consider the diagram to the right. You got a deer. Well, obviously that's a biotic factor. It's alive, but what else is alive? Trees, the shrubs, the grasses in the background. There's probably tons of microorganisms in the water. Maybe the deer has some fleas on it. Those are alive too. The abiotic factor is the water itself. Well, that's just H2O. It's not alive. The sand, rocks, lots of stuff is dead. And each biotic factor wants to live within its optimum range where it has adequate access to energy. Now I'm going to reference the board here. Hopefully you can see what's going on. What do I mean by a range? Well, let's consider ranges in biology. Think about a range numerically that you might find in biology. I have a great example. Temperature. Now, you probably keep your house, okay, at optimum level. That means the best you can have. 72 degrees Fahrenheit. Now, some people are saying, "Oh, that's too low. I'd be freezing." Or some people say, "Wow, I'd be sweating." Well, depending on what you'd like, but let's make a range out of it. Let's say really good temperature to have your house at between 70 and 74 degrees Fahrenheit. That's optimum. Now, what's survivable? Okay. Now remember, this is a range. So on either side of the optimum is something you can survive. Odds are you could probably survive with the house being somewhere between 75 and maybe 88 degrees. That'd be disgusting to live in a house that is 88 degrees all the time. That'd be terrible. But it would be something that you could do. Maybe over here you'd be freezing, but you could probably live somewhere between maybe 45 and 69 degrees Fahrenheit. You'd be absolutely frozen, but you'd survive. Anything above or below that, if you stayed in there and never could get out, you would be hurt over time. You might even die. On this side, you'd freeze to death. On this side, you would melt. Every biotic factor wants to live within its optimum range. Of course, if you are a polar bear, your optimum range is different than a deer as far as temperature goes. Your optimum range is different when you deal with what you're eating. Optimally, a polar bear gets lots of polar fish, whereas a grass-eating deer would not eat very many fish, I wouldn't think. So just consider those things when we talk about optimum ranges. Biogeochemical cycles. 3 types: hydrological, that's a water cycle. Evaporation, condensation, precipitation. Learned that in elementary school. Atmospheric recycles nutrients found in gases. So there's like a nitrogen cycle, there's carbon cycles, etc. And sedimentary recycles nutrients found in the soil and in rocks. Let's view the world. What are ways that we can view the world in which we live in? There's a couple different ways. Consider the preservationist view. Those people believe that humans are merely passing through the earth and have no claim to anything on it. There's lots of different ways this preservationist view comes out. Many of these preservationists believe that humans are actually a huge problem for the earth, that we're destroying it. And these people would be very upset at you if you walked over the grass or over an animal or something. You have conservationists advocate a wise use of natural resources, multiple uses of the land. I hope that you have an idea of stewardship in your mind. Managing nature for God as caretakers. God told us to have dominion, to rule over the fish of the sea, the fowl of the air, everything in Genesis. We need to be good stewards of that. You know what that doesn't mean? That doesn't mean that you poison the lake. That'd be terrible. Why would you do that? God made that. Remember, I was at Bob Jones one time, and there was a guy who threw 2 bottles of shampoo into the fountain that you go into as soon as you walk into Bob Jones. It's this massive fountain, and there was soap everywhere and shampoo everywhere. Not being a good steward. Not that there were not that there was anything alive in that fountain, but anyway, some people hold a unbiblical perspective, pantheism, the idea that nature is God. Now, I don't think that there's too many people going around who say things like, nature is God. But the idea is there all over the place. If you've been in a public school, odds are you've heard a lot of things like, Mother Nature does what she does best. That's a pantheistic idea. There is no Mother Nature. The earth is not a mom taking care of all of us. God is taking care of all of us. So pantheists believe that nature is God, that nature is something to be worshipped and something to be one with, as you see my picture of a tree hugger on the left. So, a waste-filled world. Pollution is any harmful substance released into soil, water, or air. As Christians, we must practice good stewardship and hear all sides of a matter before we make a decision. We must weigh in God's command. So is it ever wrong to start a fire? No. But that's going to cause carbon dioxide, something that might pollute the atmosphere. Well, there's lots of benefits having fires. For instance, if we didn't have fire, we wouldn't really be able to eat any meat. Not unless you liked your steak ultra rare, right? Uncooked. My wife always says, Mrs. Repholz says, a good steak is one that a skilled vet can still save. I disagree. I like my steak well. But anyway, let's not throw harmful substances into the air, but sometimes it is appropriate to create waste, and it's helpful. Land pollution. About 85% of our energy comes from the consumption of fossil fuels. Fossil fuels can create waste. Well, that's how we power our homes. So unless you want to go back to having no electricity, we have to use some fossil fuels. Now, we can reduce our fossil fuel usage in a wise way. We can maybe turn things off when we're not using them. That would be a wise use of our resources. But fossil fuels are useful. The use of coal is important, but we do need some coal still. Solid waste, anything unwanted like garbage, is thrown in a landfill. That's crazy. People are, it's crazy to think about the fact that if we had nowhere to put our garbage, what would we do? There just has to be places where we throw it, and allow bacteria and fungus and stuff to break it down over time. Landfill is a great area for that, but I don't think we should have a landfill every, 5 feet and make tons and tons and tons and tons of garbage. Just use what you need. Waste energy incinerator will incinerate waste. Sometimes it's even used to make what's called syngas, or synthetic gas. Air pollution. Putting harmful stuff into the air. Primary pollutants come directly from a source. Secondary comes from kind of like a secondary source. So let's say a primary pollutant you're throwing into the air: soot, smog, right, covering the air, all sorts of nasty. That's primary pollutant. Well, what happens with the smog in the air is a secondary pollutant. In fact, it can react with your lungs, destroy the alveoli of your lungs, cause chemical changes within your lungs, secondary pollutants. Lots of clean air acts around the world, lots of protocols, treaties deal with the control of air pollution. Water pollution, we had this pretty relevant to us pretty recently, as we had the red tide, a dinoflagellate bloom, where there was these microscopic creatures that took over the water and made it smell like burnt broccoli. You remember that? The entire campus just stunk, and we were miles away from the water. Point source pollutant enters water from a specific place and is easy to find. However, sometimes there's multiple sources and it's difficult to control. Pathogens, or any bacteria or virus, chemicals, macroscopic items, all these things can pollute. So if I wanted to pollute Anna Maria Island, Bradenton Beach, I could do it in a variety of ways. I don't think this is right. You could put bacteria in the water. That wouldn't be good. You could put chemicals in the water. There's all sorts of chemicals that would make the water very dangerous to accidentally swallow. I could put trash, macroscopic items in the water. I could throw like soda cans and just throw them all in the water. And that would make swimming at Anna Maria Island very uncomfortable. And there's certain types of bacteria pictured on the left called coliform bacteria. They help to measure the amount of pathogens in the water. And that's all for section 12.1. Of course, you have some homework to do, a section review 12.1. Make sure you get that done and into me. And I hope that you are having a good day. Maybe we'll be back to school together sometime soon. All right. Thank you, and adios.